Hello all, section 2.2 is derivatives. What is derivative? Let's start with the definition, right? The definition of derivatives. I did all the proofs for you for derivatives. Tonight, my job is really easy to change everything and say, oh, this is derivative, right? The derivative of a function, derivative of a function, let's name it f, at a number a, at a number a, or at a point a, denoted by f prime of a. This is the notation for derivative of a function, f prime a. As f prime a equals limit as h approaching to 0 of f of a plus h minus f of a over h. Wow, what was that? That was the slope of the tangent line to a curve. It means the slope of the tangent line in a curve, that means derivatives, correct? And that's the main formula for you for the derivatives. I don't know if your professor at algebra level explained the difference of the quotient. Maybe he told you that, hey, this is the base formula for derivatives. On that time, you had no idea what is derivatives, what is calculus, but you saw this formula before. Maybe you just missed this part, the limit part. But this part, you saw it before. Even in my previous lecture, I did the proof for you. I don't want to do it again, correct? Just here, instead of M, we name it F prime A. We read it this way, F prime A, correct? That's the derivative formula. Or maybe this one. If I name A plus H X, and if I solve this equation for H, then from here I can say H equals X minus A. And this one, my formula will become this way. F prime A equals limit as X approaching to A. Instead of f of a plus h, I can write only f of x, right? Because a plus h is x. Then I can write f of x minus, instead of f of a, right? Instead of f of a stays the same, f of a. Instead of h in the denominator, I can write x minus. Both of them is the same. Both of them is the formula to find the derivative of a function, correct? If a function is given to you, usually when you take the derivative of that function, it gives you another function. I will first do a example for you, then I'll show you a graph, and I'll show you in a graph. You should accept that, oh, when I'm taking the derivative of one function, it gives me another function, right? Let's start with these examples. Again, let me tell you, right now you are using the basic formula for derivatives. It looks difficult. Of course, it's a long way to go, but in 2.3, I gives you the laws of derivatives, like laws of limit. It gets really, really, really easy for you to find the derivatives of functions. Of course, there are some laws that they are kind of tricky. For example, the quotient law or the chain rule or the substitution method. Those are tricky, but you get enough practice until that time to know what is derivatives, correct? Let's start with a basic example. Find the derivative of a function at a given point, correct? F, example number 1, f of x equals x cubed minus x, find a formula for f prime x. That means find the first derivative of this function. Let's first write our formula, correct? Our formula is f prime x, if I'm using x, and the basic formula you had a here, but you can now change it to x, f prime x equals limit of, as h approaching, or here even to 0, and the top you had f of a plus h, now you can say f of x plus h. Minus you had f of a, here you have f of x. All of them is the same, right? Same idea over h. That is your formula, right? Look, in this formula, you need to find this piece first, and you need to find this piece first. This one is given actually to you, right? F of x is given to you because your f of x is x cubed minus x. The only thing that I want to find in this formula is f of x plus h, and it's a little bit longer algebra. Let's deal with. Hopefully everyone knows how to deal with a cube, correct? Look, if I write the function, or let me even change the color to red because it's an extra part for this problem that I will show for you. In your book directly, they put everything here. I don't like it. I wanna first find the parts, then I'll plug here in the formula, correct? The function is f of x equals x cubed minus x. Now we are looking for the f of x plus h in this function. Then I can write f of x plus h equals x plus h to the power of 3 minus, replace again x with what? X plus h. Let's simplify. Who remembers a plus b cubed? If you don't remember, you can use a plus b times a plus b times a plus b. It's one way, or a plus b squared times a plus b. But if you remember this formula, it makes it easier for you, correct? F of x plus h equals the cube. I will explain it that way. I'll use this formula, right? The cube of the first term, x cubed, correct? Plus 3 times, you reduce 1 from exponent of x, x squared, and you bring your h. Plus again 3, you reduce 1 from power of x and you add on the h. That means 3x h squared plus h cubed, correct? Also distribute the negative here to these two. It gives you negative x, negative h. Correct? That is f of x plus h. Now I have this one, I have this one, and I have this one, and I'll plug in both of them in my formula. That is the derivative formula, correct? Then I can say f prime x equals limit as h approaching to 0, In the top, you had f of x plus h. F of x plus h is actually this, x cubed plus 3x squared h plus 3xh squared plus h cubed minus x minus h minus f of x. Your f of x is x cubed minus x. Here, distribute the negative, of course, over h and simplify. Then you can say f prime x equals limit. Let's rewrite everything. I want to show you the steps. H approaching to 0, x cubed plus 3x squared, h plus 3xh squared plus h cubed minus x minus h, distribute the negative, minus x cubed plus x. Correct? Over h. You see here, negative x, positive x, they cancel out. Also, negative x cubed, positive x cubed, they cancel each other. Then you will end up with f prime x equals limit as h approaching to 0. What left in the top? In the top, I have 3x squared h plus 3xh squared plus h cubed. 3x squared h plus 3xh squared plus h cubed over h. If you plug in here 0 to the denominator, it again becomes undefined. You have to use a technique of algebra to change it from defined, right? You see in the top, all of them, they have h. You can factor out h. Then you can write f prime x equals limit as h approaching to 0. Take h as a common. What left here? 3x squared. What left here? Plus 3xh. And if you take one h out, plus h squared over h. Here, h cancels out with h, and you can plug in your limit now. Or let me even show you this step. F prime x equals limit as h approaching to 0. What left? 3x squared plus 3xh plus h squared. Plug in the value of h, it gives you 3x squared plus 3x times 0 plus 0 squared, which I missed something here. I think we have a minus h cubed minus h. We missed this h. You see, we had another h here. I'm saying why one? Let's put that minus h here. And if you take it as a common, minus 1. Sorry, I missed because it was a lot written. I missed one h. And now if I take h as a common, minus 1, correct? In all the steps, I'll add minus 1. And here, minus 1. Okay, this one becomes 0. This one becomes 0. My answer is 3x squared minus 1, which is this one is f prime of x. Later, I will introduce a formula for you. You have f of x equals x cubed minus x. Bring the exponent to the front, minus 1, and the derivative of x is 1. In one step, you can write the derivative of this function. But now you see how long you did to find the derivative of a function. Next section, you will do it in a minute or in a second, correct? I will give you all those rules. But for time being, that's your answer, correct? Now, few notes for you. You see, the idea, it's 3x squared minus 1 is another function. I told you the derivative of a function gives you another function, sometimes a number, sometimes another function, correct? Now, few notes that I want to write for you. First, other notations. What does it mean? F prime A or F prime X means actually, what is f of x? F of x for you means y. Then f prime x, you can also write it as a y prime. It means the derivative of the function. The other notation, which Leibniz actually working using this notation a lot, is dy over dx. It means the derivative of function in respect to x, the derivative of y in respect to x, because x is involved in your function. You see, it's based on x. If it was a, you can write dA, dy over dA. If your variable here is, for example, n, you can write dy over dn. Remember, dy over dx, it's not a ratio, it's a symbol. It's a symbol for the derivatives, correct? Or some people even using this, d over dx of f of x. In future, you will see we will use a lot, d over dx, or even we read it ddx, ddx of f of x. It's also another symbol or another way of writing derivatives. Or some people, this is very old notation, no one uses it anymore, dfx or dxfx. This is another way of writing the symbol of derivatives. All of them means f prime. Which ones we use a lot? This one, or this one. These are the ones that we use a lot. If you write f prime actually introduced to us too late, like after years and years that they found calculus. There was another mathematician, I forgot his name. I think he is from Canada. He introduced actually the prime notation for us. Before, everyone was using this, correct? Even Sir Isaac Newton, he used this. I think he was using dots instead of prime, or y two dots like this. He was using on that time dots on the top, but later they changed it to prime, correct? But Leibniz was using this notation, correct? You know who is Leibniz, who is Sir Isaac Newton. I did a short kind of introduction of them for you and maybe my previous lecture or the lecture before. Another important note, a function f is differentiable at a, or at a point a, at a, f prime a exists. You know the meaning of this sentence. We are talking about this point, right? If prime a exists, it means you can take the derivative here. When you can take derivative here, you're using the idea of limit. It means when the limit exists. When the point is on the curve, you can take the derivative of a function. If the point is not on the curve, how to find the derivative? You can't, right? That's the meaning of this sentence. Or you can say it is differentiable on an open interval of maybe a comma b, or maybe from negative infinity to a, or maybe from a to infinity, or maybe from negative infinity to infinity, correct? If it is differentiable at every number. Same thing that I discussed it in limits for you. If it is differentiable at every number, in the interval. AB is an open interval. If it is differentiable at AB, it means if this is my curve, at any point of this curve, my function can be differentiable. It means my function is continuous, right? If my function is continuous, if I have a hole, or if I have a gap, or if I have an asymptote, then at that point, I cannot find the derivative, correct? That should be continuous. Or the opposite way, you can say, if f is differentiable at a, then f or the function is continuous, correct? If function is continuous, it's differentiable. Or the other way, you can say f is differentiable at a, it means function is continuous. It's both way. Let me write the other way also for you. You can say f is differentiable it's really a long word, differentiable at a, then the function, or then f, which is your function, is continuous. It's the other way of talking about derivatives, correct? Let's do one more example, then I'll stop the lecture. Of course, there are many examples. Let's take something simple. For example, f of x equals x squared plus 3x. Find f prime x. Correct? Again, your formula, f prime x equals limit as h approaching to 0 of f of x plus h minus f of x over h. First, you have to find f of x plus h. If the function is f of x equals x squared plus 3x, then f of x plus h equals x plus h squared plus 3 times x plus h. If you simplify this, it's equal x squared plus 2xh plus h squared. I'm using a plus b formula. Don't be shocked why he is writing so fast. Instead of x plus h, if you are slow, you can do this, x plus h times x plus h, right? You will end up with this. And also I am distributing 3 here, plus 3x plus 3h. Also, what is f of x? Here, this is your f of x. I'll plug in this one and this one in my formula, and I'll simplify. I can find easily f prime x, right? Then I can write f prime x equals limit as h approaching to 0, f of x plus h is this long, x squared plus 2xh plus h squared plus 3x plus 3h minus f of x. Your f of x was x squared plus 3x, right? Over h. Distribute the negative. To save a little bit of space and time, I will do this. If I distribute the negative, this one becomes negative, this one becomes negative, right? Now let's combine like terms. Or even let me keep the red color. Now you see positive x squared, negative x squared cancels out. Positive 3x, negative 3x cancels out. Then you end up with f prime x equals limit as h approaching to 0, excuse me, 2xh plus h squared plus 3h over h. Factor out h, then limit as h approaching to 0. If I take h as a common, I will end up with 2x plus h plus 3, right, over h. H cancels out with h. F prime x equals limit as h approaching to 0 of 2x plus h plus 3. Plug in h0, it gives you 2x plus 0 plus 3. It means your answer is what? 2x plus 3. That is actually f prime x. You see, a function is given. When you take the derivative, it gives you another function. One more thing to tell you, we have first derivative of a function. We can take the second derivative of a function. We can take the third derivative of a function, fourth, fifth, sixth, nth derivative. The notation will be here. F prime, first derivative. F double prime, second derivative. F triple prime, the third derivative. After that, f to the power of 4. It's not power, it means the fourth derivative. Or if you have dy over dx, when you are using this notation, first derivative. If you write d2y over dx here too, it means the second derivative. This is the notation. This way we go to the third, fourth, sixth. Later, after, not right now, I'm not asking you to find the second derivative or third derivative because using this formula is too long. But as soon as I give you the rules or the laws of derivatives, then we look also to find the second derivative, the third derivative. Maybe at this time it looks kind of useless for you, but soon you will see when you find the second derivative of a function, it has a meaning. When you find the third derivative of a function, it has a meaning. What is that value actually? Soon you will learn slowly, slowly all of those ideas. That was, this is all about your 2.2. I'll stop the lecture right now and see you next time in 2.3.